Hi, my name is Felicia, and we're going to be completing video homework 3 for Professor Song. So for problem 1, we have our given values. N is 60, P is 80%, and we get 0.20. We're talking about the hit and the misses. I will say I went to tutoring for help on problems 1 and 2, so that didn't go as well as planned, so it's going to be hard for me to explain what all we're looking at, but this is our sample mean and our standard deviation. We have 10 is less than or equal to 48. And then you have 10 is less than or equal to 12. These are they're supposed to be bell graphs. Wait, it didn't really make sense, but we have 49.85% for problem 4. And it can give you a rough estimate of the probability of events. Now, problem 2, we also kind of have the same thing. We have the stuff that we were given up here. So our mean, our standard deviation, and n. So mean is 60, standard deviation is 2. And you do 12 over the square root of the standard not the standard deviation, the n, to get your standard deviation. Now, z equals 1.5 and p equals 0.93. We use the T184 calculator to do this. Over here you have your bell graph. We didn't know the mean. And 0.93 would be, which you would get rid of this, and it'd be 93% is the probability. So if you take a sample population from the normal population, it becomes normal in respect to the normal population. For number 5, you have 1.2. You allow more intermediate values to get in to decrease it. And then 6 is n becomes larger as sample mean gets closer to the actual mean. For problem 3, you have what we were given. Our z-score is approximately 1.96. Our sample mean plus or minus z times this. We do all of that math and we get 3.039 and 3.261. It means that if this sampling process was repeated many times, about 95% of the intervals computed would contain the true mean. This is our bell graph, the shaded area, this is the mean, and I want to say that is your sample mean, if I'm remembering correctly right now. So, number 4, 99% confidence, the z-score is approximately 2.576. Your mean of error is 0.14. Your new intervals are right here, and then the 99% interval is wider than the 95% interval. This reflects the greater confidence where we're more certain the interval contains the true mean, so we allow a broader range. This is 5 and 6, question 4. So you have your standard error, which is 0.04, and then your margin error, I believe is what that stands for, is 0.078. The intervals over here, and then the interval is narrower than before. A larger sample size reduces variability, giving us a more precise estimate. And then the higher confidence level is wider interval, so more credibility, less precision. And then the larger sample size, a narrower interval, is less uncertainty and more precision. Question number 4. We kind of have the same thing going on. We have what we're given. This is our hypothesis, our sample hypothesis. No, that's the real hypothesis. This is the approximate hypothesis, and it's one-sided because the consumer groups suspects the mean is less than the 12. So you have your standard error, which is over here, 0.03795. Your z-sat stat is negative 2.11. Your p-value is going to be 0.017. Now, p is 0.017, which is going to be less than 0.05, so it'll reject the null hypothesis, which is statistically significant evidence that the average soda content is less than 12%. Your bell graph, you have 12, and then that's like your mean, and then you have your negative 2.11, which is our z-stat, in the shaded area where our numbers are. Now 5, it says that it represents the probability of observing a sample mean of 11.92 or lower if the true mean is 12. A small p-value, the one we have, means this outcome is likely under the hypothesis, providing strong evidence against the null hypothesis. Now, question number 5. You have your sample mean, all of your given stuff. Your hypothesis and your null hypothesis is a two-sided test because the wide testing, where I can't read my own handwriting, testing for any changes in the mean. You have your standard error, which is approximately 5.165. Your t-stat's going to be approximately negative 1.162. And then your df is going to be 14. 3, you have your 1.162 is less than 2.145, so it fails to reject the null hypothesis. I believe is not enough evidence to conclude that the diet changes average cholesterol levels. We have our bell graph with 11.92 here, and then the sample mean of 12 right there, negative 2.11, which is where our shaded area is, which is what is correct. For 5, we have ME, so our margin of error is 11.08. Our interval is over here. It's the 182.92 and 205.08. The interval includes 200, supporting our decision to not reject the null hypothesis. Now, your t versus your z. Both of these test the hypothesis and the mean, and both use the standard error and critical value. Now, z-tests assume known population standard deviations, and t-tests use sample standard deviation and adjust for small sample sizes. T-distribution is wider and more conservative for small numbers. Thank you.